Hello students, this is Mrs. Levinson. Welcome to Lesson 10.03 Stars. Make sure that you go into your course content and you download the PowerPoint for Lesson 10.03. And this is what it looks like, and you can always download it. Once you download it, it should open in a PowerPoint program and you can take notes on it. As you go through Lesson 10.03, make sure that you are reviewing the goals. By the end of Lesson 10.03, you should have covered all of the goals on this slide. You did some in 10.01, some in 10.02, and the rest in 10.03. As you go through the lesson, you should be taking some notes on what stars are made of. Stars are important because the life cycle of a star and how you know which path the life cycle the star will take. There are two paths. The types of stars and how they are classified. The Hertzberg-Russell diagram, and I'm going to go over that a little bit with you because it's just a graph. It's really just a graph, but we'll talk about what it means here in a second. And to be able to explain the difference between absolute and apparent magnitude. So as you go through Lesson 10.03, you want to go through the slides of the lesson itself, which is the textbook. Click into the textbook. And notice it has this slide format again. And you make sure that you do click on the Quizlet. That's a live link. You can click on it and go study your vocabulary words. As you go through here, here's the star. This is what the star, like the layers of the star and how a star is structured, what it looks like. This talks about fusion. And remember, fusion is when particles collide. So if you have two atoms of hydrogen, they will collide and combine into a single atom of helium. And when that happens, it gives off lots and lots of energy. And this can happen with all kinds of atoms, not just hydrogen. You can have a hydrogen and a helium, or a helium and a helium, and so on, and bigger and bigger and bigger. Hydrogen is just the smallest, that's all. And as you go through, it talks about why stars are important. You don't have to write this down word for word on your notes, but at least write down the basics. So try and make it shorter, but get the basics there. This is the life cycle of the star, and as you go through the life cycle, notice there are two pathways. There's the top pathway and the bottom pathway. The top pathway is the pathway that the small and medium-sized stars take. Stars like our sun. Our sun is one of the medium-sized stars, and as it goes through this pathway, it's right here is what the stage our star is in, and it's giving a lot of light and heat energy. And when it runs out of fuel, runs out of hydrogen, it'll go into that red giant stage, and eventually it'll go through a small explosion, and then you'll be left with planetary nebula with a little core. And that core is called a white dwarf. So as that nebula dissipates off into space, what you're left with is this little white dwarf, which is just basically the core of the star. And as that core runs out of energy, out of fuel, it will dim and dim and dim until there's really no light given off, and that's when we call it a black dwarf or a brown dwarf. The large and extra large stars go through this bottom pathway, and they are often very bright, and they are very, very massive. And as they run out of fuel, they will turn into these red supergiants. And when the red supergiants goes through a supernova, right? So the small and medium stars can go through the nova. That's when it does that explosion, right? And then the large and super large, they go through the supernova, right? And that's when they are left with this nebula. And in the center, you can have one of two things, either a neutron star or a black hole. So the large ones might make the neutron star, and the extra large ones would make the black hole. So that's the life cycle of a star. And when we talk about stars, the way that we classify stars are two ways: temperature and luminosity. And the word luminosity may be a word that you don't know, maybe you haven't heard of it. So luminosity actually means brightness. How bright is it? Hotter stars are usually brighter stars, right? Not always, but usually. And brighter stars usually means they have a higher temperature. Again, not always, but usually. But luminosity is the brightness. If you get a light bulb and you're looking, well, how bright is the light bulb? And one of the numbers they may give you is the lumens, L-U-M-I-N-S, the lumens. That can give you some idea of the brightness, but that lumens means how bright it is. All right. This is a little bit about how stars are born. You can read through that. Make sure you read through what main sequence stars are. Let me give you an example. Our sun is a main sequence star. And when we talk about main sequence, we really are talking about this Hertzberg-Russell diagram. And this Hertzberg-Russell diagram is really just a graph. It has an x-axis, it has a y-axis, and they're plotting the temperature of the star on the x-axis, right, versus the brightness of the star on the y-axis. And when you talk about the brightness of the star, you're talking about absolute magnitude. And you have to understand what absolute magnitude means for this Hertzberg-Russell diagram to make sense. So we're going to skip ahead a couple slides and come back. So let's talk about absolute versus apparent magnitude. And this is probably a good place for you to take some notes on your PowerPoint, right? So absolute magnitude is how bright is the star actually? How much light is that star giving off? The apparent magnitude is what does it look like to us? So if we're standing on Earth at night and we look up into the sky and we see stars and we say, oh, hey, there's a dim star and there's a bright star, that's how they look to us, right? That's apparent magnitude. One appears to be brighter than the other, but is it really? Is it bright because it's really close? Or is it bright because it's giving off a lot of light? It could be really far away, but giving off so much light it looks bright. Or it really could be a dim star, but it looks bright to us because it's very, very close. So here, when you talk about absolute and apparent magnitude, you have to think about distance as well as brightness. Apparent magnitude is just what they look like, whatever the distance. But absolute magnitude, an easier way to really think about it is if they are exactly the same distance, one will be brighter than the other. That's the actual amount of light it's giving off that's causing that brightness because they're the same distance away. So absolute magnitude is how bright is it really? How much light is it actually giving off? If both stars were right next to each other and they're the same distance from you, you could measure how much light is being given off by each star, and then that's the absolute magnitude. So now let's go back and look at our Hertzberg-Russell diagram. Notice the bottom is the temperature, to the left is a cooler temperature, to the right is a hotter temperature. Okay. No, I got that wrong. Sorry, look at the arrow. To the left is a hotter temperature, to the right is a cooler temperature. Hotter, cooler. Hotter to the left, cooler to the right. Got it? Absolute magnitude, look at the arrow. Bright at the top, dim at the bottom. So down here at the bottom, you may have very dim hot stars. And over here, you may have very cool dim stars. So cool dim, hot dim. Up here, there's very bright. High absolute magnitude, but this is a cool and bright star, and way over here on the right at the top, it's a low temperature, but it's a high brightness. And so they can plot, they being the scientists, the temperature and the brightness of stars, and you can see most of these stars follow along this line here in the middle, and that's the absolute magnitude and temperature. This blue area, that's the main sequence stars, like our sun. Our sun actually falls, whoops, sorry, let me go back a slide. Our sun actually falls right about in here on the main sequence stars. Okay, so it's just a graph. This is exactly the same graph, but instead of absolute magnitude, they called it luminosity. But I want you to understand absolute magnitude and luminosity are the same thing. Absolute magnitude and luminosity are the same thing. It's the brightness. You can say the relative luminosity or the absolute luminosity. The Hertzberg-Russell diagram is that absolute brightness. So you can see our sun is kind of right in the middle of that main sequence area where most of the stars fall. Okay, big, cool, and bright, small, big, hot, and bright up in the top left, and small and cool and dim down here. Okay? And this one actually gives you some numbers to help you out a little bit. And you can see where each of these stars fall as far as size, brightness, temperature. You can use the bottom numbers to help you with the temperature. 3,000 is a lot cooler than 25,000. And you can use this to tell you the luminosity. So this is actually 10 to the -4. I know it's kind of hard to see, but that's 10 to the -4. That's a really small number. That's 0.00001, right? And this is 10 to the 4, so 1 with 4 zeros after it. All right. So as you go through these slides, take some notes, go back and read them word for word. And then if you have any questions, ask me. Have a great day.